So the damage that is effected to the host, that the damage that is caused by a pathogen to the host on a per pathogen individual produced basis. So that is for a pathogen replicates and a pathogen produces a certain number of individuals and causes a certain amount of damage to the host. So the amount of that damage can be more important to the pathogen than it is to the host. So what do I mean by that? So an expedient pathogen can be one that in fact produces fewer pathogen progeny, fewer pathogen individuals for a given amount of host damage. So you're going in, you're damaging the host in the course of your replication or in the course of your life cycle, and you're producing fewer progeny pathogen individuals per the amount of damage that you're causing. And that could be more important to the pathogen, which is ending up with fewer individuals being produced, than it is to the host organism, because the host organism, at least on that per effort by the pathogen to reproduce basis, is being damaged the same amount. To the host, what's more important is the total amount of damage to tissues, since that amount of damage should roughly correlate with host fitness or inversely correlate. So the higher the amount of damage, the lower the host fitness. So it's the total amount of damage that gives rise to some total amount of reduction in host fitness. The parasite is trying to maximize its reproductive output. And this is especially to the extent that maximizes its transmission effectiveness. Although there can be a maximization of parasite reproductive output that does not result in a maximization of transmission efficacy. And it is the trade-off between those two things, attempting to maximize reproductive output and attempting to maximize transmission effectiveness, that can lead to what I've been describing as the parasite's dilemma. Virulence is a function not just of parasite reproductive output, but also the amount of tissue damage that results from that output. So if a parasite could set things up so that it had a high reproductive output without damaging its host at all, then it would not be displaying virulence. But the flip side to that is that a parasite variant that may in fact display a larger amount of virulent impact on its host, a large amount of damage in the course of its replication, might have an advantage over the non-damaging parasite, if such a thing could even exist. And as a consequence, selection within the parasite population can be for an increased amount of damage, and thus you have the potential for parasites evolving the potential to damage their hosts. The trick is to not have so much damage, however, that you result in a reduction in the parasite's ability to be transmitted. As a rule, the restraint required to display less virulent infection strategies, so again, you would have an expectation that even if you could have a parasite that was able to reproduce without hurting its host, it may be invaded by parasites that in fact can replicate faster at the expense of damaging their hosts. That even so, we might have an expectation that these parasite populations may not evolve indefinitely towards ever-increasing virulence, because those infection strategies that display less virulence might result in greater potential for the parasite population to be transmitted. So as a rule, the restraint required to display less virulent infection strategies may only involve to the extent that pathogen populations within a single host are closely related. So if there is an optimal level of virulence, competing pathogens may exceed that virulence by attempting to display greater within host virulence. If you have a population that is clonally related or otherwise closely related, then that population may not have the same level of competition, if if only because the individuals within that population will not necessarily display any genetic variation. And if you don't have genetic variation, you can't have evolution for increased virulence because there is no variation, genetic-based variation in virulence within the population. So if you have a population of pathogens that's initiated with just a single individual, is clonal, or otherwise is very closely related, you may not have sufficient genetic variation within that population to allow for an evolution of ever greater virulence within that population infecting a single host. As a consequence of this, you can have populations infecting different hosts competing against each other, and it will be those populations that are more effective at transmitting that will ultimately transmit more progeny, and that level of virulence that gives rise to the most effective transmission, as displayed by a population of parasites infecting a single host, will be the level of virulence that natural selection will tend to favor. Even though if you had within-host competition going on, you might exceed that level of virulence. The trick, of course, is to avoid that within-host competition by keeping cooperating individuals cooperating with one another and excluding those individuals that instead would be cheaters.